Welcome back to the Domain Relational Calculus Part 3. So in the previous video we were doing this query. So let us return back to the same query. So the query was find the names of all customers who have an account at all branches located in Brooklyn. So here we require three different relations, namely customer, branch and account, and one more relation is also required, depositor. Now let us see what all information is contained in these relations and why we require these four different relations. See, the customer relation consists of the customer name, customer street and customer city, and we require the names of the customers. Then this relation consists of the detailed information of the customer, but this customer street is not of more importance, so we can omit this attribute, and we here use two different domain variables, namely C and N, where N is representing customer city. Now the second relation we are using is branch. This branch is a relation which consists of branch name, branch city and assets, and what we require is that the branches are located in Brooklyn. So what we require is that the city should be Brooklyn, and this branch city information is contained in the relation branch. Then what we require is that the customer should have an account at that branch, and this account information is contained in the relation account, which has the account number, branch name and the balance. So this account number is the account number of the customer, and this account number of the customer is in the branch. So in the branch relation we have used the domain variable X for branch name. So here we are using the same domain variable X for representing branch name. Now because he has an account, then that account is related with some table, and there we have the account number. So this information is contained in the relation depositor, where this account information is stored, and this information is also, so this account number is a attribute which can join these two relations, and we can get the customer information here, which can be matched with the information of the customer in the customer relation. So the name of the domain variables for customer name is C, because it is one complete query and is not using any any or union or intersection. So here it is one complete query. So the name of the domain variables for customer name is the same. For branch name we see same variable X. For account number we have the same domain variable A, and that's all regarding the variables. So now let us write the query. So what we want to output is, we want to output the name of the customer. So the name of the customer is represented by C in the relation customer. So we want to output C. Now this customer relation consists of two so this output variable is over. So after using C, so customer is the relation. This consists of two different domain variables C and A. We have already used C, so what is remaining is N. So we use N also. So because this customer name is used so many in so many relations, so here wherever is, because this customer name is in the depositor also, and this depositor, so whenever we will be using depositor, then we will not be using this particular domain variable again, because this is already been used. Okay. So from the customer we have completed. Then the condition is that he should have an account at all the branches. So the branch information is contained in the relation branch, where the branch information is X, Y and Z domain variables for branch name, branch city and assets. So branch relation consists of three domain variables, and for all of these domain variables, so this, when we write for all XYZ is in branch, So it will consist of all the branches, but the condition is that all the branches should be located in one particular city, Brooklyn. And for city we represent the domain, we represent city with the domain variable y. So the condition is that the y is equal to Brooklyn. So now here we have identified all the branches in the Brooklyn. So what is required, that if the branch is Brooklyn, then that customer should have an account, and it should also have the information regarding how much amount he has deposited. The account number of his, so that we can get the balance from the account relation. So the account relation consists of three different attributes: account number, branch name, and balance. So here account number is already we have used for in the account number attribute of the depositor relation. So this attribute name, domain variable name for attribute account number will be same. So here in the account relation we have A, X and B. So A, X and B is in the domain variable names with the relation account, and we have already used X with the for all existential qualifiers. So the variable X is already used with the for all existential qualifier, and Y was also, X was used from here as an existential qualifier, and this was there in the account. So this X is used, and here we have also used Y and Z from the branch here for all X, Y, Z. So all these three variables are used, domain variables are used, and this also consists domain variable is also there in account. So we have used this. So now we were working on this account relation, and from this account we have already used X. So what are the two different variables that are still remaining are A and B. So we use A and B with the existential qualifier. So these two variables are also used. Now because we have used, what we will do is we have used this account relation which consists of A, X and B. So here A, X and B, and from A, X and B we have already used the variable X. So only A, B are remaining. So A, B we have completed from the account relation also. Now the last relation is the depositor, and this depositor consists of the two domain variables C and A. So C and A, and we don't use any existential qualifier here because C is already used and A is already used by this existential qualifier A. So if we want to interpret this query, then what does this say is that the set of all customer names. So here the set of all customer names tuple C, with all these customer names are represented by the domain variable C, such that for all tuples X, Y, Z, if branch city is equal to Brooklyn. So for all tuples X, Y, Z where branch city is equal to Brooklyn, what is true, that there exists a tuple in the relation account with account number A and branch name X. So there exists some tuple in the relation account with the account number A, and X is there already in the branch. So it will see all the branch names over here where the city is equal to Brooklyn. Then that tuple should also exist in the depositor relation, and this depositor relation has the two domain variables C and A. A similar query of this form is like find all students who have taken all courses offered in the biology department. So here once again we require multiple tables, because for finding the information of students and the courses and the department, so the information of the student is contained in the student relation with different attributes: ID, name, department name, and total credits represented by I and DT. Then the courses they are taking is in the relation course, which represents course ID, title, department name, and credit. Now because the course ID is different from the student ID, so we use different variable for course ID, and that is X. Title, department name, and credits. Credit here is also different from the total credits earned by the student. So we use variables, domain variables x, y, z and w for these 4 different attributes. Then another relation is the takes, and this takes relation has the attribute id, course id, sec id, semester, year and grade, where id is a student id, so we use the same variable name, domain variable name I. Then the course id is from the same relation course, so we use the same tuple domain variable x for course id, and then sec id, semester, year and grade are different attributes which are not used earlier, so we can use any name from there. So what is required is we want to find all student, so it can be we can either find their id or we can find their name, but here we are finding the id, so id represents the domain variable I, so I is our output variable. Then the student relation consists of I and dt domain variables, and from these domain variables I is already used, so the remaining are I and dt, and so we use them with the existential qualifier. So what is required is that all the courses which are run in biology department, so for all courses we use the existential qualifier for all, and this course information is in course relation. This has 4 different attributes x, y, 4 different attributes represented by domain variables x, y, z and w. So we want to check for all the different attributes, so these are used with the existential qualifier. Now for all these courses where the department is biology, what is required that that particular course should be taken by the student. So the student takes those courses with the help of the relation takes, where we have I, X, B, R, P, Q as the domain variables for different attributes, and because I is already used as an output domain variable, X is already used in existential for all qualifier, then the other universal quantifier for all, then the other remaining are B, R, P, Q, which are listed over here. Next comes the safety of expression. So whenever we write some expression in the domain relational calculus, how do we ensure its safety? So what is required is that in a domain relational calculus we use 2 different quantifiers, there exist and for all. So consider this expression where we have used existential qualifier, and this existential qualifier is also used with the negation part. So when we test this query, then this part has no problem because this is a safe atom, but this atom which consists of the negation, that means not. So whenever we use not, so when the second part says not, and there are so many values that do not appear in any relation. So in order to make this query safe, what we require is that we should not use these atoms. So in order to prohibit expressions which are not safe in relational algebra, we have the following conditions to make the expression safe. And the first condition is that the all values that appear in tuples of the expression are values from domain P. So whatever is the output, so that output is the name of the domain of the attributes. It can be any attribute, any number of attributes could be there in the relation which are denoted by the predicate, and the value of the expression should be from any one of those attribute values. Then the second condition is for the expression to be safe is for every there exists a formula for of the form there exists some x for p1x. This formula holds true only if there is a value x in domain p1. So there should be some value. If that value is not there, then we should avoid that predicate. Similar condition holds for all also. In the this expression is written for all x p1x. So this formula is true only if this p1x condition is true for all the values of the domain p1. So for all the values which are contained in domain p1 with respect to all the attributes, this condition should be used. So that is why whenever we use this for all quantifier, we use all the domain variables over here, because the condition should be for all the variables. So this is similar, this is an example of this third condition which holds true. So that's all in this video. Thank you for watching.